last lesson we talked about gradient, and in particular looked at finding the gradient of a line. First we started with gradients that were whole numbers, and then we looked at gradients that were fractional. We talked about the idea of gradient being for every horizontal increase, how far does the vertical value go up, the y value in essence. However, that doesn't work for all gradients. It's hard to tell when you don't have a 1 unit horizontal increase when you've got a nice whole number in terms of if you haven't got a nice whole number as a vertical increase. And so then we went on to fractional gradients and looked at that idea of rise over run. So I want to go back to this 1 unit horizontal increase, these sorts of lines here, because that's going to link to the work that we do on our tables of values, because they're generally nice whole numbers, or integers at least. So going, for every 1 unit across, we go up 2, or that one, or for every 1 unit across, we go down 3 for that particular line. So what's happening is, every time we go up by 1, that your y value is going up by that same amount each time. And ideally we want that to be a nice integer, but it might not be. And so with our table of values, which is coming up, and I know some of you have already looked at this, the idea is how do we connect what's going on with the table with gradients? And you should already be familiar with this because you've done it since probably year 8, definitely in year 9. Some of you may not have used the term gradient in year 8, but you're definitely doing these difference patterns and so forth. But it does link to that gradient. So when we look at this example where our x values are going up by 1, so that's our horizontal increase, what's happening to y? So y is going up by 5. So think about this, 1 unit horizontal increase, your y value, so every time x goes up by 1, your y value is going up by 5. What's that representing? The rise over the run, or your gradient. And so if we're trying to find the equation that connects the variables, the x and y, it links directly to that, our equations of the form y equals mx plus c. So from doing that, what we call a constant first difference, that value there, that 5 is the gradient. It allows you to help find or determine the rule, because we know that's going to be y equals 5x. And your c value is what? What can you tell me? Where do we get this?
0.
Yeah, that's the 0 value. That's your y-intercept. Well, the y-intercept occurs, not a good colour to use when you've got green underneath. That's your y-intercept. And that occurs when x equals 0 on the table. Okay, try the rest of these. What's happening to our y values as x is going up by 1? So our y values in the second one are going down by 4. So we say the gradient or the constant difference is -4, which is essentially the gradient of the line that we use to plot those points. And then what's our y-intercept? Nothing. Well, there is one there. We just need to back project. So what do we have to start with to take 4 to get 11? That's 15. And let's say we're too far away to get that 0 value. You can always do a substitution. Put in a point. If we put in 5, we need to get -5. So -4 times 5 is -20. How do I get to -5? I've got to add 15. So I'm going through this quite quickly because you should be familiar with it. It's stuff you've seen multiple times before. And then the last one, the last standard one is what I mean. What's happening here? What's happening to these y values? As x goes up by 1, your y values are going up by that constant amount each time. That's how we know it's linear. It's got to have that constant amount, that constant change. What's happening here? Well, is it linear? It's not, actually. Because this is 1, and that's 3, and that's 5, and that's 7. So you're not going up by that same amount each time. So I think determine it so it's not linear, so we don't need to know the equation. And then that last one, slightly different. What's different about this one? It's not going up by 1, so your run is actually 2 each time. Your rise is 3. This is your constant difference. But because your x values are going up by 2 each time, what's happening to your y values? They're going up by 3. Your gradient is fractional. And so your m value, your gradient, is 3 on 2 or 1.5. And then we've still got our y-intercept that we need to determine, and we can back project that to -1. So this is the, I've done something wrong?
Isn't it supposed to be not negative, not take 3? Because that's only 1 away. So the other one is 2.
Oh yes, thank you. Thank you. I'm glad someone's awake. Yes, you're quite right. That take 3 is wrong because it's only 1 away. So it should be take 1.5. Now, had I, so that's not -1, but it should be a half. So had I checked that with another point, I would have worked that out, but I didn't, so I was a bit slack. So let that be a lesson to you. Check it with another point. 1.5 times 5, 7.5 plus a half gives me 8. So just check it with another point there. All right, and then we've got the last few. So have a go at these ones. See if you can come up with them yourself this time. So in that last one, we're trying to find that constant that we're adding at the end. It is a bit tedious to try and back project all the way to 0. So this is where you can check it with a point. If I put in 10, my x value is 10. I know it's -2 because it's dropping down by 2 each time, so that's the gradient. Dropping down by 2 each time. -2 times my x value is 10, so that's -20. How do I get to 9? What do I need to do to -20 to get to 9? I've got to add 29. And then check that with another point. Try it with 13. -2 times 13 is -26. I add 29 and it gets me to 3. So that's how you can check to see if you've got that right. Any questions about that? No. All right, that should be nothing new to you anyway. And the last thing, we've already talked about these lines, but just to formalise it very quickly, here we've got horizontal lines, vertical lines. Now, what did I say yesterday? Horizontal lines, what can you tell me about their gradients? Horizontal lines have a gradient of what? 0. So horizontal lines have a gradient of 0. Vertical lines, what can you tell me about their gradient? Undefined, yeah. So horizontal lines with a gradient of 0 still follow the y equals mx plus c rule because they still have 0 gradient. The c value is just that y-intercept. So here's my horizontal line. Y equals 3.5. If I want to, I could say 0x plus 3.5, but really we prefer to write that as just 3.5. And so often you'll see has the form y equals k, y equals a constant, because that gradient is 0. So 0 times whatever x is, it doesn't matter. If you want to think more logically, it doesn't matter what x is, y is always 3.5. So the equation y equals 3.5 might still make sense like that too. Vertical lines are different because the gradient's undefined. We can't write that in the y equals mx plus c form. But for every vertical line, your x value is always the same. So following that same logic, in terms of your y value, our x value is -4.5 in this case, and no matter what y is, x is always that. So that's how we can remember the vertical line equation. And there's the general form there. X equals. So that's the only exception to your y equals mx plus c rule. Every other line can be written in that form, y equals mx plus c. So what would line B be then? This one. X equals, it's a vertical line, every value is x on that, x equals what on that line? Every value is x equals 1, every point. And the last one, y equals 2. Every value horizontally, doesn't matter what x is, y is always 2. Oh, negative 2, yes, sorry, under. Someone said 2 and I just went with that. All right, what about the x-axis? What's the equation of the x-axis? That one. X-axis is? 0, yeah. Well, a bit more information. Y is always 0. And the y-axis? X is always 0. All right. So there's some questions to practice, but we'll leave that for now. We'll come back to the linear stuff after the test. So just to be clear, and I've got it on record, none of this stuff is in the test, right? Your equations is not in the test. It will be in the next test though, okay? It's all stats and normal distribution, this test.